Problem 2. 40 students are having a track and field tournament. Track and field is basically, around the school track. People would run, say, a 100-meter dash, 50-meter dash, 800-meter run, I guess. And there's also field activities on the middle field. So that's just kind of a brief introduction to what track and field is. There are 26 students who are doing running activities. So for running activities, there are 26 students and 18 that are doing fielding activities. Because of other reasons, 6 people didn't get to go to the tournament. So the question is, how many students participated in both the track and fielding activities? Doesn't seem much different from the last 2 problems you just solved in the other video. But there is one important piece of information that is new. This sentence right here, because of other reasons, 6 people didn't get to go to the tournament. So now what would our Venn diagram look like? So as you may remember, last time we went through the method of a Venn diagram, which is a diagram that really lists out the information in all of those twists and turns that bring you along, that the problem brings you along when reading it. And that's just the key to solving the inclusion-exclusion problems. So drawing and being able to create that Venn diagram is very important. So in this problem, really the question is, how do we draw that Venn diagram? Well, first we see there are 2 categories. Okay. There are 2 categories. But right here, there's an extra 6 people that didn't participate because of other reasons. So I added a rectangle around. You could have used any shape actually, but I just didn't use a circle because that would confuse me. So this was the Venn diagram that I drew. So what did you draw? Anyway, we know that there are 40 students. So the reason why I included this smaller Venn diagram inside this rectangle is because this whole rectangle has 40 students. And the amount of students that are part of the tournament that is included in this Venn diagram. But there are still 6 students that didn't go. And this whole rectangle includes both of those types of people. So outside right here in this boundary, there are 6 people. Now we need to focus on the athletes who went, the students that were part of the competitions. And this isn't much different now from our other problems. So this left circle, this would be running activities on the track. Over here would be fielding activities. So for running activities, there are 26 students, and for fielding activities, there are 18 students. So how many students participate in both? So we're trying to find this. Okay. We know that in total there are 40. So let's first totally find the total number of people that's inside these 2 circles. And we can get that because we know that not every single one of those 40 students were able to go. So we first subtract the 6 from the 40, leaving us with 34 students, which means that in the circles added up, it equals 34. But instead, 26 plus 18 is greater than 34. So just like always, we subtract 34 from it, so we get the recounted part. the part that was counted twice, the excess part. So 26 plus 18 equals 44. 44 minus 34 equals 10. So the answer is 10 students. So this isn't much different, and in almost all of our next videos, we will be dealing with problems that include this extra rectangle, or maybe even more complicated ones. So really the key point here again is to always analyze the problem and to always really think about how your analyzations can lead you to different ways you can draw your diagram.